my name's Heidi Lovett, and I'm from Colorado State University, and I just studied observing the effects of heat during exercise. So first, a little bit of background. Heat and cold temperatures are something we have to deal with in the environment every day. And so during working out, if you're working out outside, sometimes you can't always turn on the air conditioning or pump up the heat. Oftentimes, these hot and cold temperatures will result in an adverse effect to exercise and performance. There are a few ways that they've found to combat this by adequate diet and hydration, by maintaining a balanced diet throughout the day, and also making sure that you're well fed during and before exercise can decrease these effects. They've also found that by pre-cooling your muscles beforehand, it can help with the hot environments during some workouts. So, the purpose of my experiment was to see these effects and to test 6 different variables that can happen during them. So, there's some research out there studying these effects. There definitely needs to be more research done to not only reconfirm the research that has been done, but also to see other avenues and to combine different variables together. During my study, I studied 3 males and 3 females that were on the USCSA cross-country skiing team at Western State College located in Gunnison, Colorado. These 6 individuals were all relatively fit, not only because it was a ski season, but they were also able to be on the ski team, and they participated in my study. The tests that were done were on a treadmill located in the High Altitude Performance Lab in Gunnison, and the test looks similar to this picture where there's someone that's hooked up to a gas analysis mask, so their noses are plugged and their mouths are essentially in a device that looks like a snorkel, and whatever they breathe out is then connected to tubes that goes to a computer that analyzes what they breathe out. I also tested heart rate, which was done by a heart rate strap that was placed around their chest, and then it was relayed to the computer. The lactate threshold, this is the threshold at which your body starts producing lots of lactate, and lactate is a naturally occurring substance in your blood, but at the point at which it starts producing a lot of lactate, that's when your body is working too hard to maintain that level of exertion. So that's when you get done with a run or a bike and you notice how that evening or even the next day your muscles are often really tight and sore, and you just can't quite do the same level of workout that you did the day before. That would be you passing your lactate threshold. And so this test measures the exact level or the exact point at which you are passing it. And this is done by a small pinprick in your finger, and it is then taken to a device that then measures your lactate, and that is done every 4 minutes during this test. The air analysis, that's what the picture is showing and what I talked about before. The temperature, I did the body temperature before the test and after the test underneath your tongue just with a thermometer. The rate of perceived exertion is simply on a scale, and during the tests I just asked the participants to point to the number that they felt that they were working at. And the sweat rate was done by measuring the people's body weight before the test and after the test to see the amount of liquid that was lost. During this test, all the participants did the treadmill test twice. Once during just normal conditions wearing a shorts and t-shirt at 70 degrees Fahrenheit, and once wearing a hat, a very large winter coat, and sweatpants to simulate hot conditions. This test was a Bruce protocol test, and what that is simply a test where you start out at a level grade and a slow speed, and slowly you start going to a steeper grade and steeper speed or faster speeds, and this just slowly works you up. And yeah. So for my results, I have graph here represents the females and males in the subjects. The females and males were always split apart in the results because there is a significant difference between females and males' performances. For the blue represents during the normal conditions or the baseline, and the red represents during the perceived hot exertion test. And as you can see, there is quite a significant difference in the heart rate at lactate threshold. So at that level where they're just about to go over into non-recovery zone, that is when these heart rates were measured at. And as you can see, these heart rates were significantly higher, and that indicates that the body is at a higher level of exertion at that point, and there's a higher level of stress on the body at that point as well. This graph shows the carbohydrate versus fat usage. This was done using the gas analysis test, and carbohydrates and fats are used during exercise as an energy source. Carbohydrates are indicative of a very hard, strenuous exercise because they're much easier for the body to utilize. Fats are indicative of a very easy exercise where the body can take its time and use up its fat stores. So in these two, the first graph is under baseline conditions, and the second is under hot conditions. And you can see the level of fat usage is dramatically decreased during the hot conditions, so your body is having to work harder at the same level. And my other variables that I measured were temperature. The results were inconclusive because of the machinery malfunction, which is okay, it happens. The sweat rate was approximately half a pound across the board for both hot and cold conditions, and both males and females. So there wasn't any real large variance in that. The rate of perceived exertion was slightly higher at lactate threshold under hot conditions, but it wasn't high enough to be statistically significant enough. And these things are some things that maybe if I were to perform the test again or perform it with a larger sample size, the numbers might turn out different and I might have more statistically significant numbers. So overall, there is adverse effects during heat and exercise. More research still needs to be done to not only test what these effects are, but to also see several ways that they might be able to combat these effects and maybe even prevent or stop them from happening during exercise. And here are my references.